Whenever quadratic is written in the vertex form, automatically you can know what the vertex is. If we were to graph this and compare it to the graph of y equals x squared, then we would see that the vertex of this one, compared to the vertex of 0, 0, would have a shift of 4 units to the left and 2 units down compared to 0, 0. That's the vertex, -4, -2. The next thing that we know about parabolas is that they're symmetric. And that line of symmetry is called the axis of symmetry. Now, the axis of symmetry can be found by drawing the line, the vertical line, that passes through the vertex of the parabola. So we could call this the line that cuts the parabola in half. This is the axis of symmetry. Now the axis of symmetry, the vertical line equation is going to be x equals -4. The reason why it's x equals -4 is because every vertical line, or if we think of all of the inputs on this line are going to be -4. Next, we can find 4 other coordinates. Now, these 4 other coordinates that are on the parabola, this will help us figure out what the shape of the parabola is based on our function. So let's pick 2 x values on one side of the line of symmetry. So I'm going to choose -2 and 0. I'm going to take a -2, substitute it into the function, so we could think of what is f of -2. -2 minus 4 is 2, squared is 4, minus 2 is going to be 2. So we have -2, 2. Now for our other coordinate, 0 plus 4 is 4, 4 squared is 16, minus 2. So f of 0 is 16 minus 2, which is 14. And so then we have 0, 14. Make sure that when you're graphing these, you label every single one of your points. So now you can kind of see this shape forming, and it's going to be a U-shaped graph. Okay, so there's half of my parabola. Now, in order to find the other half, we know that, again, the parabolas are symmetric. That means that each point on this side has another point that has the same output on the other. So if we just used our, I'm just going to use this to kind of keep the, nope, that's distracting me. So now we know that this coordinate has an output of 14. And we know this coordinate has an output of 2 because of the symmetry of the parabola. Now I can go ahead and draw in my parabola because I know where the other 2 coordinates are located. But in order to really complete this problem, we need to actually know what the inputs are going to be. And so, if we want to solve for this, we have to substitute in, we need to use the axis of symmetry. So let's see how far. How far is -2 from the axis of symmetry at -4? That's 2 units, right? -4 and -2 are 2 units away. That means that this coordinate, x coordinate here, is also going to be 2 units away from the axis of symmetry. So -4, 2 units away from -4, is going to be the coordinate -6. Now let's go for the other one. Okay, how far is 0 from -4? 0 is 4 units from -4. What number is also 4 units from -4 on the other side? Well, that is going to be -8. And so if we were to summarize this, our 4 coordinates are going to be, our 4 outputs are going to be f of -2 is equal to 2, and so is f of -6. F of 0 is equal to 14, and so is f of 8. Now, if we really wanted to check and make sure, f of -8, that this is correct, let's go ahead and just put in our other coordinates. So we have -6 and -8. -6 should have an output of 2, so -6 plus 4 is -2 squared is 4 minus 2, which is 2, so that checks out. And then -8. -8 plus 4 is -4 squared is 16, minus 2 is 14, so that also checks out. So again, looking at vertex form, when graphing it, you can find the vertex first, then the axis of symmetry is the vertical line through the vertex, drawn by the dotted line. Choose 2 x values on one side of the axis of symmetry. Find the outputs, then use the axis of symmetry to find the points to the left.